So next we want to find out the area right of a g value. Okay, in under a standard normal curve. So what does that mean? Meaning that what is the area right of this? Because in the last video we were finding the area left of a number, left of g equals to something, right? And then what we did, we went to second and then vars, and then we did normal CDF, and then on the left area you were putting the two bounds, left bound and the right bound, right? In the right area also, so suppose you want to find out this right area, right of g value. Okay, what we do is you do normal CDF, and then the left bound will be that number. Now right bound will be 10 to the 99 in this case, right? Because it keeps going on the right, so you pick a very big number on the right bound. The left bound is given here. Okay, and then on this also, so left bound is that value, and then right bound will be 10 to the 99 and so on. Okay, let's do example number 4. Find the area right to g equals to negative 0.95. So what you do is, this is the standard normal curve with mean 0, is because it is saying, talking about g, that's why mean is 0, right? And the right to negative 0.95, it is negative 0.1, negative 1, negative 2, negative 3, like that, and then positive 1, positive 2, positive 3, but it says right of negative 0.95. So 0.95, negative 0.95 will be somewhere here, right? Close to negative 1, right? And you want to find out all the area right of that. Okay, so since it keeps going on the right, so what you do is the left bound on this shaded region, for this shaded region, the left bound is negative 0.95, right? This is negative 0.95, and the right bound may be somewhere here, right? You can do 10 to the 10, positive 10 to the 10. Okay, and then you will be able to find out the area. Okay, let's do that in the calculator. What you get is, let me clear this, go to second, vars, and then normal CDF is the number 2, and then hit enter. Now what is the left bound? Lower bound is negative 0.95, right? Negative 0.95 here, and then the upper bound will be 10 to the 10, right? So 10 to the 10, you can do that way. And the mean is 0, sigma is 1, because it is the G distribution, right? This is G distribution, that's why the lower bound is a number and upper bound is a big number, right? And then 0 and 1, because we are finding the right area, and then hit enter. So this is what you enter in your TI-83. Normal CDF and left bound, right bound, 0 and 1. Okay, if you hit enter, then you get 8289, 0.8289. Okay, that is basically 82.89%. So what you get is basically, this is 0.8289, that is basically 82.89%. So what that means is the area right of negative 0.95 is 82.89%. For TI-83, it will be normal CDF. The left bound is negative 0.95. Right bound is 10 to the 10, right? And then 0 and 1 are the default values. So if you do that, you will get 82.89%. So I always recommend you guys to make a figure and then shade the region that it asks. It says find the area right to that, that is right to that one. And if you shade that, then you will know which one is the left bound and what should be picked as the right bound. If there is no bound on the right, you pick a very big number. If there is no bound on the left, if you are finding the left area, if there is no bound on the left, then you pick the negative 10 to the 10, so as we did in the previous video. Okay, let's do that one. Example number 5. Find the area right to or right of g equals to 1.09. I think it is better to write right of g equals to that, right of, right, not right to, right of that. So how that look like? That looks like, if I draw the graph, so this is the standard normal distribution, mean is 0, right? This is 1, 2, 3, like that, negative 1, negative 2, negative 3. But in this problem, you are asked to find out area right of 1.05. 1 is here, right? 1.05 maybe somewhere here, very close to 1. And you are asked to find out area right of that, right? So you are asked to find out area right of that. So you are asked to find out that. So this point is basically 1.05, right? So how do you do that? Is again, you should do normal CDF, right? So you'll do normal CDF. So the left bound or the lower bound on this shaded region, right, is 1.05, 1.05. Upper bound is, it is open. That's why you pick a big number, 10 to the 10. And then since this is the G distribution, mean is 0, sigma is 1. Since it is G distribution, so you write 0 and 1. Okay. So what do you get? Let us use the calculator for that. Let me erase what we had there and then go to second, vars, normal CDF, and then hit enter. Okay. So the left bound is 1.05, 1.05. Right bound is 10 to the 10. That was 0 and 1. Okay. If you paste that, hit enter. This is the thing you will use in your TI-83. You enter the left bound, right bound, and then 0 and 1. Okay. If you hit enter, you will get 14.68 or 69. Okay. That will be 0.1469. 0.1469. Remember that if you are finding the area under a normal curve, you round up to, you pick 4 decimals. Okay. That means you round up to the 4th decimal, so that will be 14.69%. That is the area right of 1.05. So 14.69%. Okay. So the last thing that you are asked to, you will find the area is if 2 values are given. For example, if you are asked to find the area between this G value and that G value, what you do is you enter left bound is this number, you enter right bound that number, and then you do 0 and 1. Okay. Similarly here, left bound, right bound, left bound, right bound. Okay. So you use calculator for that too. Let us do example number 6 and then you will see. In example 6, it says find the area between G equals to negative 0.95 and G equals to 0.27. Okay, these are the G. That means your mean is 0, sigma is 1. Okay, so mean is 0 in the middle, sigma is 1. So what you do is the question says that G is negative 0.95. There is negative 1, negative 2, negative 3, positive 1, positive 2, positive 3, right? Negative 0.95 will be somewhere here. You see that? And then what will be 0.27? Similar to that one is negative 0.95 will be close to negative 1, right? This is negative 1, negative 2, positive 1, positive 2, like that. And 0.27 will be somewhere here, right? Close to 0. You see that? And you are asked to find out this middle area under that. So how do I do that? Is you will plug in, this is 0.95 negative. This will be 0.27, right? So that is your, okay. Now you are asked to find out the area between, that means you are asked to find out this shaded region. Okay. So how do I do that? Is you go to the calculator again. Okay. So go to the calculator and then go to enter the left bound, right bound and everything. Let me clear what I have. Second, vars, and go to the normal CDF and hit enter. What is the left bound here? Negative 0.95, right? Negative, this is negative 0.95. And what is the right bound? Is 0.27, 0.27, right? And 0 and 1 are default values because we are talking about the G distribution or the G values. And in your TI-83, the same steps will be, and after you do the normal CDF, you will get blank here, okay? And you enter the left bound of this shaded region, right bound of this shaded region, and 0 and 1. And if you hit enter, you will get 4353, 0.4353, right? So that will be 0.4353, that is 43.53%, right? So what is the TI-83 syntax? Is normal CDF, left bound is negative 0.95, right bound is 0.27, and then 0 and then 1, right? 0, 1. So if you do that, that's what you get. Similarly, the last one is find the area between 1.05, 1.75. How would that look like? So this is G distribution again. Okay. So 0 is in the middle because it is G distribution. It says 1.05. So 1, 2, 3 somewhere here, right? So how would the area between 1.05 with is close to 1? That is 1.05, right? 1.75 will be close to 2, right? And you are asked to find out this middle area. You see that? So 1.05, 1.05, and this is 1.75. So how do I do that? Is go to the calculator and then find the area. So let me clear everything I have. Go to second verse and then go to normal CDF. And then what is the left bound is 1.05. So what you do is 1.05 and the right area is 1.75, right? And then hit enter, 0 and then 1 and then paste. Okay, so if you hit enter, this is the calculate syntax for TI-83, left bound, right bound, 0 and 1. And if you hit enter, you'll get 10.68, right? 10.68%, or you can say 0.1068. So that will be 0.1068. So that is 0.1068. That is 10.68%, right? And that is same. So the TI-83 syntax is normal CDF. Left bound is 1.05, right bound is 1.75, and then 5 and then 0 and then 1, right? If you enter that, you will get 10.68% or 0.1068. So this is how you find out the area between two G values, or left of a G value or right of a G value. Okay, now, so normal distribution, the area under the normal distribution curve can be used to find out the probability distribution. Okay, the area under the standard normal distribution can also be thought of as a probability or as the proportion of the population with a given characteristic. Let us see that. For example, if it were possible to select a G value at random, the probability of choosing one of the G values, say between 0 and 2, would be the same as the area under the curve between 0 and 2. In this case, the area will be 0.4772. Okay, so what does it say? That's what it says is, suppose you have a normal distribution, a standard normal distribution, 0 is here, right? So what is the area between 0 and 2? So this is 0, G equals to 0. This is G equals to 2, right? Because 1, 2. So the area between these two numbers, 0 and 2, right? 0 and 2, 0 and 2. Area between these two numbers is same as probability of picking a number between 0 and 2, right? So what you can say is, you can say that probability that G falls between 0 and 2, 0 and 2 is same as probability of this, because if you pick any number between here, or any number from negative infinity to positive infinity, I would say, it keeps going to negative infinity, it keeps going to positive infinity. That's why we write a big number for positive infinity and smallest number for the negative infinity. We do it 10 to the negative 10 to the 99, or 10 to the negative 10 to the 10, or positive 10 to the 10, that way. So the total number are on this line. All the numbers between negative infinity and positive infinity are this line. So what is the probability that if you pick a number between negative infinity and positive infinity, what is the probability that that number lies between 0 and 2? Will be same as probability of picking any number between 0 and 2 is same as the area of this region divided by the total area. Divided by the total area will be just 100% or 1. So you can find just this area to find out the probability that G falls between 0 and 2. So that will be, if you go to just what we do to find out this probability is find the area between 0 and 2. So how do I find the area between 0 and 2? It's just exactly the same way. What you do, second verse and then number 2, right? Hit enter, and the left bound is 0 for that shaded region, right? What is the upper bound or the right bound is 2, right? And then 0 and 1, so is, see, 47.72. That's what you get, 0.4772 or 47.72%. So 0.4772 or 47.72%. So basically, if you are asked to find out area between two G values, or if you are asked to find out the probabilities between two G values, it is exactly the same. You just use calculator and find the area between those two G values. For example, probability that a G value falls between 2.25 and 2.95 is written as probability of G between 2.25 and 2.95. You can write less or equals to or less than, it doesn't matter here, okay? It's same as the area under the normal curve between two G values. What is happening there is basically, so G is 0, in the middle, mean is 0, right? Since we are talking about G values there. And then where is 2.95 and 2.25? So 1, 2, 3, right? 2.25 maybe somewhere here, 2.95 maybe somewhere here, and you are asked to find out this area, or finding the probability that G falls between 2.25 and 2.95 is same as finding the area between two numbers. So this is 2.25, so this is 2.95. Now you use calculator to find out the area between those two numbers, right? How do you do that? Second verse and go to the normal distribution, number 2. So 2.25, 2.25, and then the other one is 2.95, 2.95. If you hit that, and then since we are still in the G distribution, because it says G between this and that, so that is basically this is the normal CDF, left bound, right bound for that shaded region, okay? And then 0 and 1. If you hit enter, you get 0.0106. That is basically 0.0106. That is 1.06%, right? So you can use normal CDF, right? Left bound is 2.25, right? Right bound is 2.95, and then 0, 1, right? So you separate them by comma, 0, 1. If you do that, you will get this number, okay? So basically, finding the area between two G values or finding the probability between two G values are the same thing, okay? Let us do example number 8, okay? I am going to do example number 8. So what it says is, find the probability for G less than 0.45. How do I do that? So what it says is, let us draw. I suggest to draw the figure for each problem it asks, okay? G is less than 0.45 means there is a normal distribution. 0 is in the middle because we are talking about G value. Now 0.45 is like somewhere here is 1, somewhere here is 2, right? 1, 2 like that. But what is 0.45 then? So 0.45 may be somewhere here, right? And you are asked to find out all the area left of that number, right? So left of that number will be, what will be the left bound? Will be negative 10 to the 10 because it goes through infinity, right? Let's take a smallest number, negative 10 to the 10. And right bound will be 0.45 because that value is 0.45. So how do I do that? So that area or that probability that G is less than 0.45 will be same as it is normal CDF, the left bound is negative 10 to the 10, right? Right bound is 0.45, and then since we are talking about the G value, it is 0, 1. And if you use calculator, what you get is, let me show you that. That will be second verse, okay? Normal CDF, hit enter. It is negative 10 to the 10, so it will be negative 10 to the 10, smallest number, right? And then the another is 0.45 is the right bound, and then 0 and 1. And if you pass this is what you get. You will have to enter in your TI-83 if you are using that. 6736, right? That will be 0.6736. That is same as 67.36%. This is what you get, okay? Or the second one, you have like this is that normal distribution, 0.23. You are finding G greater than 0.23 means this is 1, right? 0.23 will be somewhere here. Let me use different color for that. So 0.23 will be somewhere here close to 0. And then you are trying to find out all the area right of that because it says greater than. This was saying less than means left, greater than means right, right? So you are trying to find out that. So what will be the probability then? So it will be, so this value is 0.23, right? 0.23. So probably that G greater than 0.23 is same as normal CDF, The left, what is the left bound on this shaded region is 0.23, 0.23. And the right bound, it keeps going to the right? You should pick a big number, 10 to the 10, right? And then 0, 1. You should do that, okay? And then if you use calculator for that, what you get is clear angle secant verse normal CDF, right? The left bound is 0.23, 0.23, and then the right bound is 10 to the, because it's a big number on the right? 10 to the 10. And then mean is 0, sigma is 1. Hit paste, hit enter there. This is the TI-83 syntax, right? And hit enter. You got 4090, okay? That will be 4090 decimal. That is 40.9%. That's what you get. 40.90% or 9%. Similarly, for the third one, how does the graph look like? What I would do is just draw the horizontal line and draw the bell-shaped curve. 0 is in the middle because we are talking about G. Negative 1.23, negative 1, negative 2, negative 1.23 will be somewhere here. Positive 2 will be positive 1, positive 2, somewhere here, right? So let me say the region that we are asked to find out. Negative 1.23, negative 1.23, positive 2. That's what we were saying, that middle region, right? So this value is negative 1.23. This value is positive 2, right? So how do I find out that then? So it will be probability that negative 1.23 less than G is less than 2 is equals to, just use normal CDF. Normal CDF needs left bound is negative 1.23, right? Right bound is 2, and then 0 and 1 because we are doing the G distribution, right? So let us use calculator for this. How do I use calculator? Is you do the secant verse and do the normal CDF, right? Hit enter, and then what is the left bound is negative 1.23, so negative 1.23, and then the right bound is just 2, right? Just 2. Mean is 0 and sigma is 1, right? So do the paste, hit enter. This is what you do in the TI-83. Hit enter, you get 8679, okay? That is 0.8679, 0.8679, which is same as 86.79%, right? So the last example here is greater than negative 0.18, okay? So greater than, this is mu is 0, negative 0.18 will be close to 0, right? Like that. And you are finding the area right of that because it says greater than, means all the values right of that, right? How do you do that? Is probability of G greater than negative 0.18 is same as you do normal CDF. What is the left bound? That is the negative 0.18, right? Negative 0.18 is the left bound. What is the right bound? You go through infinity here because you keep going on the right? That will be, you pick a big number, 10 to the 10 is enough. 10 to the 10, or you can write 10 to the 99, that's fine. And then mean is 0, sigma is 1 because we are talking about G, okay? So use calculator for that. What you get is when you use calculator, you get, let me clear that, secant verse and then normal CDF. Left bound is negative 0.18, right? And then another one is upper bound is 10 to the 10, right? 10 to the 10, okay? And then mean is 0, sigma is 1, you paste it, okay? This is how you enter. By the way, I forgot to tell you this. If you are using TI-83 calculator, you need to separate them by comma. So where is comma? There is a comma symbol there, right? You need to use that comma to enter, to separate those. Okay, let's hit enter. This is where you get 57.14. So 0.5714, that is 57.14. Did I round up to the 4 decimal place? Let me check, okay? Let me make sure that 57.14, that's okay because there is a 2 after 4, right? So 57.14%. That's what I do. Okay guys, so this is how you find out the area between two g values or probability between two g values. All right, thank you.